question at hand involves three 100 amps main lug-only panel boards in a high-rise building, each fed with four number 2 American wire gauge conductors from a single 100 amps fused disconnect switch through a junction box. Inside this junction box, the 3 panel feeders are spliced to the incoming feeder from the 100 amps fused disconnect switch. The central question is whether any of these panel feeders can be considered a tap under any of the rules of Article 240 of the National Electrical Code, or if this is simply a T-splice, and whether there are any code restrictions on this application. The analysis hinges on the definition of a tap and the requirements for splices within the National Electrical Code. A tap is generally considered to be a conductor that has an ampacity less than that of the feeder conductor it is connected to. In this specific scenario, the 3 panel feeders each have an ampacity that is equivalent to the feeder from the fused disconnect switch. Therefore, these panel feeders do not meet the definition of a tap according to the National Electrical Code. The configuration described involves a T-splice. This is where the 3 panel feeders are connected to the incoming feeder in the junction box. The National Electrical Code permits T-splices. However, they must be made in accordance with the requirements outlined in Article 110.14. Article 110.14 of the National Electrical Code addresses the electrical connections. This section provides requirements to ensure that electrical connections are mechanically sound and provide a good electrical connection. The intention of the requirements in Article 110.14 is to prevent issues such as overheating and loose connections which could lead to equipment failure or pose a fire hazard. Specifically, Article 110.14 covers the general requirements for connections. It mandates that connections and splices must be made using suitable methods. This includes using approved pressure connectors, terminal bars, splicing devices, or soldering, with listed soldering lugs. The connections must also be suitable for the material of the conductors being used. For example, when connecting aluminum conductors, the connectors must be specifically listed and identified for use with aluminum. This is because aluminum expands and contracts more than copper with changes in temperature, and it also forms an oxide layer that can impede electrical conductivity. Therefore, special connectors and joint compounds are needed to ensure a reliable connection. Article 110.14b addresses splice requirements. It mandates that conductors must be spliced or joined with splicing devices that are listed or identified for the use. The splices should also provide electrical and mechanical continuity of the conductors. Article 110.14c covers the temperature limitations. This is an important aspect of making electrical connections. Because conductors and terminations have temperature ratings, the goal is to not exceed these ratings. Conductors are typically insulated with materials that have specific temperature ratings. For example, a conductor with a 75 degrees Celsius insulation rating can safely operate at a higher temperature than a conductor with a 60 degrees Celsius insulation rating. Terminations, such as those found in panel boards, circuit breakers, and other equipment, also have temperature ratings. These ratings indicate the maximum temperature that the termination can withstand without degradation. To comply with temperature limitations, it is essential to select conductors and terminations that are suitable for the expected operating temperature of the circuit. This involves considering the ampacity of the conductors, the ambient temperature, and any heat generated by adjacent conductors or equipment. It may also involve directing the ampacity of the conductors if they are installed in an environment with a high ambient temperature or if they are bundled together with other conductors. In summary, the electrical connections must adhere to the temperature ratings of the conductors and terminations to prevent overheating and ensure the reliable operation of the electrical system. The National Electrical Code provides tables and guidelines for determining the appropriate conductor size and ampacity based on the operating temperature and other factors. The requirements outlined in Article 110.14 are intended to ensure that the electrical connections are made in a safe and reliable manner. By using suitable methods and materials and following the temperature limitations, electrical professionals can minimize the risk of electrical failures and ensure the long-term performance of electrical systems. In this specific application involving T-splices, there are no explicit code restrictions. However, compliance with Article 110.14 is essential. This means that the splices in the junction box must be made using connectors or splicing methods that are listed for the purpose. The connectors must be suitable for the size and type of conductors being used. They must also be properly installed to ensure a secure and reliable electrical connection. Considerations for the specific installation should also be taken into account. Firstly, conductor size and ampacity must be appropriate. The conductors must be sized appropriately for the load they will be carrying. The overcurrent protection device, which is the 100 amps fuse disconnect switch, must also be sized to protect the conductors. Secondly, the working space around the equipment must be adequate. Sufficient working space must be provided around the fuse disconnect switch and the panel boards to allow for safe and easy access for maintenance and repairs. The working space requirements are outlined in Article 110.26 of the National Electrical Code. Thirdly, proper grounding must be ensured. The grounding system must be properly installed to provide a low impedance path for fault currents. This helps to protect against electrical shock and minimize the risk of fire. Article 250 of the National Electrical Code covers the grounding and bonding requirements. Fourthly, the panel board rating must be adequate. The panel board must have a voltage and current rating that is suitable for the intended application. The short-circuit current rating of the panel boards must also be sufficient to withstand any potential fault currents. Fifthly, proper labeling must be in place. All electrical equipment, including the fuse disconnect switch, panel boards, and conductors, must be properly labeled to identify their purpose and function. This helps to prevent confusion and ensures that maintenance and repairs are performed safely and efficiently. Sixthly, compliance with local codes and regulations is mandatory. In addition to the National Electrical Code, local codes and regulations may also apply to the installation. It is important to check with the local authorities to ensure that the installation complies with all applicable requirements. In conclusion, the three 100 amps panel feeders in the junction box are not considered taps as long as they maintain the same ampacity as the feeder from the fuse disconnect switch. The connection of these feeders in a T-splice configuration is permitted provided that all splices are made in accordance with Article 110.14 of the National Electrical Code. There are no additional code restrictions specific to T-splices in this type of installation, but adherence to general wiring practices and relevant articles of the National Electrical Code is crucial for a safe and compliant electrical system. The initial question of whether the panel feeders constitute a tap is resolved by understanding the definition of a tap in the context of the National Electrical Code. Since the ampacity of the panel feeders is not less than that of the incoming feeder, they are not classified as taps. The emphasis shifts to ensuring that the T-splice is executed correctly and in compliance with the requirements of Article 110.14. This includes using suitable connectors and splicing methods that are listed for the application and ensuring that the connections are mechanically sound and provide good electrical continuity. Additional considerations include conductor sizing, overcurrent protection, working space, grounding, panel board ratings, labeling, and compliance with local codes and regulations. By addressing all of these aspects, electrical professionals can ensure that the installation is safe, reliable, and compliant with all applicable standards. The National Electrical Code serves as a comprehensive set of guidelines for electrical installations, and it is essential for electrical professionals to have a thorough understanding of the code and its requirements. The code is updated every 3 years to reflect changes in technology and best practices, so it is important to stay up to date with the latest revisions. In summary, the installation described is permissible under the National Electrical Code, provided that the T-splice is made correctly and all other applicable requirements are met. The focus should be on ensuring the safety and reliability of the electrical system by following industry best practices and adhering to the code. It is always recommended to consult with a qualified electrical engineer or inspector if there are any questions or concerns about the installation. A qualified professional can provide guidance and ensure that the installation meets all applicable requirements. Finally, it is important to remember that electrical work can be dangerous. and it should only be performed by qualified individuals who have the necessary training and experience. Working with electricity can be hazardous, and it is essential to take all necessary precautions to prevent electrical shock and other injuries. Always to energize circuits before working on them and use appropriate personal protective equipment, such as gloves and safety glasses. By following these safety guidelines, electrical professionals can minimize the risk of accidents and ensure that electrical work is performed safely and efficiently. In addition to the technical aspects of the installation, it is also important to consider the environmental impact of electrical work. Electrical equipment can contain hazardous materials such as lead, mercury, and cadmium, and it is important to dispose of these materials properly. Many jurisdictions have regulations governing the disposal of electrical equipment, and it is important to comply with these regulations. Additionally, it is important to conserve energy and reduce the environmental footprint of electrical systems. This can be achieved by using energy-efficient equipment, such as LED lighting and high-efficiency motors, and by implementing energy management strategies, such as occupancy sensors and programmable thermostats. By considering the environmental impact of electrical work, electrical professionals can help to protect the environment and promote sustainability. In conclusion, the installation described is permissible under the National Electrical Code, provided that the T-splice is made correctly and all other applicable requirements are met. The focus should be on ensuring the safety and reliability of the electrical system by following industry best practices and adhering to the code. It is always recommended to consult with a qualified electrical engineer or inspector if there are any questions or concerns about the installation. By following these guidelines, electrical professionals can ensure that electrical work is performed safely, efficiently, and in compliance with all applicable standards.